Hi, everybody. Welcome to week 6. This week we'll be talking about quality. There's going to be two main sections. The first one is more of a qualitative overview, understanding key terms with respect to quality and total quality management. We're also tying in a lot of the work of Edward Deming and his influence on Japanese manufacturing and what we know today as lean manufacturing. So today we're going to talk about some of those key terms, and then the next section of the quality module will be focused on statistical process control. That is also a supplemental chapter within the text. So if you have any questions about how to do that, about how to do any of those problems in the statistical quality control section, please let me know, but I'll try to walk through that with you. But for now, these are just some key terms to make sure you're familiar with. So quality, of course, ties back to strategy, as does every major component of this course, which goes back to understanding how the organization is going to gain that competitive advantage, which again can be through differentiation, through low-cost leadership and response strategies. Quality specifically helps to either increase a firm's sales because you have a better reputation, you're able to respond more quickly to customer needs or changes, but you're also, those same principles, those same techniques that you're using to increase quality that make the customer satisfied are also in many cases actually bringing down the price point of the product or the service. Initially, as you start quality programs, you may put more money up front into trying to get them off the ground. So I think there's a bit of a misunderstanding that if you invest a lot of money and time into quality initiatives that it's just going to increase the overall cost of the product or service you're delivering. But that's not necessarily the case. I think for organizations that do this really well, creating quality systems is really a cultural aspect. There are some very low-cost things that you can be doing to identify problems on a daily basis and to continually improve them. And those low-cost solutions also help to bring down the price point of the product or the service overall. So again, these are the two methods. So increasing quality is going to result in sales gains, again, through either increased or improved response, sometimes through flexible pricing and improved reputation to the customer. But we're also going to be reducing those costs by having higher levels of productivity, also having fewer rework and scrap costs and lower warranty costs as well. So when it comes to defining quality, there's a lot of different ways to define it. There's some great professional organizations if quality is something that you're interested in or you do for your job. The American Society for Quality, ASQ, is very active. There's a lot of different chapters within New York State in most major cities. So in Rochester and Syracuse, downstate, there are ASQ chapters. So ASQ has their own definition of quality, but which it more reflects kind of total quality management perspective. But I think it's important to be able to differentiate, as is the text, in terms of the different types of views on quality, because it's not that easy to define. So there's the user-based approach where you're focused on quality as being something that is it has a higher performance, right? The customer thinks that it's more desirable because it's got more features, it looks cooler, it's new. So there's what the customer perceives to be higher quality, which usually means that you're comparing it to other products or services that are on the market. From an internal standpoint, there's a manufacturing-based view of quality, which is basically your ability to produce or deliver a product or service that meet certain standards, right? So this can be tolerances, specifications, making sure that as you define quality internally within your system, that you are meeting the expectations that you set for yourself. And there is another, a third type of view in terms of what is quality, and it's referred to as product-based, and that is when you really have aspects of the product that you deem to be higher quality. And again, this is oftentimes in comparison to another product or service. So you could say that our product is higher quality because if we're talking about craft beer, because we use more hops in our beer. If we're talking about clothing, it could be because we use cotton with we've got a higher thread count. So there's a lot of different product-based applications or ways we can think about quality as well. And all of these apply in the service industry as well. One quality award to make sure you're aware of is the Malcolm Baldrige National Quality Award. So the Malcolm Baldrige Award is given out every single year. there are multiple different categories. There are manufacturing-based quality awards. There's also quality awards given to the service sector and also to education. And it was established in 1988. Again, this is when that total quality movement was really kind of in its heyday. And it was designed to promote these total quality management practices that we were realizing were so vitally important, but the West was a little bit later to pick up on. So some recent winners. So we've got a school district, we've got Lockheed Martin, Xerox, Henry Ford Health System. And basically what the Malcolm Baldrige process is it is a huge application, and it's something that most companies do on an annual basis. Maybe they won't apply every year, but they still use that same kind of the fundamental process of aligning their strategic goals and their operational metrics, that the work that's done on a daily basis to determine how they're doing with respect to quality, how many defects there are, and then using continuous problem solving to address these problems and prevent them from happening in the future. So a lot of companies have invested a lot of time and energy into creating a really comprehensive system to make sure that quality is a part of not just what they do when you're working on the manufacturing floor, but that quality permeates even the back office applications in terms of making sure that you're doing a good job with having all of your paperwork be correct, that you're responding to customer needs and demands and questions in a timely fashion, and making sure that everybody throughout the entire organization has clarity on the strategic goals and objectives of the organization and feel as though that they're empowered to make a change if they see something's wrong. Another quality award or standard that's really important in industry, specifically in manufacturing, is ISO 9000. For those of you that are working in manufacturing, you're probably very well aware of ISO 9000 and what these standards entail. It's very similar to the Malcolm Baldrige Award, but instead of being kind of an award that you get a trophy, ISO 9000 is kind of like if you want to bid certain jobs in a certain industry, you have to have it. It's basically like the minimum expectation in terms of being able to be a supplier for some of the big companies that have products that need very tight tolerances and specifications. So making sure that you have all of your manufacturing operations set up to be able to support meeting that whatever the quality standards are consistently over time, and that you have all of these organizational structures in place so that you can do that continuous improvement and problem solving. ISO 9000 takes that into account, and there's over 1 million certifications, and basically ISO 9000 is in almost every single country. Any major manufacturer is going to have it, irrespective of where they are in the world. So as we talk about these big quality awards, whether it's the Baldrige Award or whether it's getting nice ISO 9000 certified, ethics and quality management are kind of fundamental to both of those things, and to any business that wants to do anything well. Making sure that you're delivering healthy, safe, quality products and services on a consistent basis, making sure that the people who do the work on a daily basis, it doesn't matter whether you're at the top of the food chain, if you're in management or the C-suite, or if you're, the janitor, cleaning up on the shop floor, that everybody is a part of this organization and moving the organization in the same direction. And it's kind of like, if you see something, say something. So if there's ever any quality defect, or if you realize that something's not going right, you have to kind of step in and feel empowered to be able to not only say something about it, but also be a part of the problem solving. With respect to ethics, there will be an ethics question on the homework, and I'll also be linking to a video, GlaxoSmithKline video, which is a 60 minutes from about 10 years ago. Even though it's a little bit older, I think it's a good reflection on just how challenging. It's easy to kind of gloss over and say, of course, there are ethical components to operations and quality work that we have to consider, but I think we face them more often than we really kind of discuss openly. And so hopefully that video will also be not only interesting, but also will hit home in terms of just how difficult creating an organization that has quality embedded into the culture can be. So we can't talk about quality improvement without also talking about continuous improvement. And again, this is going back to Edwards Deming in that PDCA cycle of making sure that as we identify problems or opportunities, that we identify what's going on. We're collecting some baseline data to understand what the issue is. We make a plan or a hypothesis about, if we do this, then we think this is going to happen. So then we actually test and run an experiment to see, if we make a change, is that actually going to reduce the number of quality defects we're seeing? And then what's really important is that we come back and we check to see whether or not it worked. So many organizations, in an effort to fix problems, are just firefighting on a daily basis. So trying to address all of the problems that come in and fix them so that the customer or the client's happy, or the next person in the process, but that doesn't necessarily prevent that error or that issue from happening in the future. So part of the PDCA model that is vitally important is, if we have a hypothesis, if we think something is going to make a difference in terms of improving our quality or improving a process, that we actually run it as a true experiment and we see whether or not it works. And then based on what we learned, we adjust accordingly. Either we keep that countermeasure in place and we let everybody know about it, or if it doesn't work, that's okay. It's just an experiment and we can learn from it irrespective of whether or not it worked or not. And we can come up with something new, a new hypothesis, to see if that will help us, again, increase our productivity or operations or improve our quality. A couple terms that are really important when we're talking about continuous improvement is, the first is Kaizen, and this is a lean term. The literal translation is Kai is to take apart, Zen to make new, and it's basically talking about the process improvement process is going through and understanding in detail how your processes work, the step sequence, the timing of those processes. And this goes back to what we had talked about last week in terms of creating standard work to create a baseline, understanding our processes, and making little changes to try to improve them. So when we talk about, people use Kaizen, most people use it interchangeably with continuous improvement. It's that process of those PDCA cycles, running experiments, seeing if we can make a difference, and then doing that cycle over again, all in an effort towards to getting a little bit closer to our overall, the strategic goal or the mission of the organization. TQM stands for Total Quality Management. Total Quality Management was very popular in the 80s and the early 90s. Lean and Total Quality Management really have the same roots. I think most people would refer to their quality and process improvement practices now as being lean, and including some of those techniques and tools and that thinking in terms of how do we interact and engage the people that work in the system and change that culture to support a culture of continuous improvement. Again, we don't hear TQM being used a lot. Some organizations still use it, but really those two terms are used, TQM and lean, really kind of fundamentally sort of mean the same thing. Another term that you might hear is zero defects. This was forwarded by Joseph Juran in terms of how we think about quality. In most cases, actually in most Western organizations for a long time would say that they're okay, there's an acceptable number of defects. Whereas in Eastern companies and cultures, especially in Japan in the 80s and early 90s, they all kind of took on a zero defects mentality, in that there's no acceptable number of errors, especially if we're talking about high reliability organizations that are either, right, we can think about healthcare, we can think about defense, we can think about the energy industry, where aerospace, where if you do have one defect, that can have kind of catastrophic implications. So even if you're not in a high reliability industry, setting our sights for zero defects is really kind of the fundamental thinking in terms of getting us a little bit closer every day, and not kind of accepting that there's some sort of level of quality defects that would be acceptable to the organization. Another term that you will hear a lot, many of you probably already heard it based on the organizations where you work, Six Sigma. And Six Sigma has two meanings. So there's a statistical definition, and that statistical definition is if you can achieve Six Sigma quality levels, your system or your process is 99.9997% capable. And that translates to essentially, if you had 1 million opportunities, if your production run, it was creating, if you were had a million parts coming off of your production line, having a Six Sigma level of quality would equate to only having 3.4 defects per million opportunities. So for every million products that are coming off of your line, you have less than essentially 3 defects. So that is really, really difficult to achieve. This was forwarded by GE in the 80s and the early 90s in terms of trying to get their manufacturing operations to Six Sigma levels. We hear a lot of companies and organizations talk about Six Sigma. Most of them do not refer to trying to get to statistical Six Sigma levels of capability within their systems. And we might hear this in healthcare. And we're not even at 1 Sigma levels in healthcare. Most organizations, when they talk about Six Sigma, they're talking about the program aspect or definition of Six Sigma, which is essentially a program that's designed to reduce defects, lower costs, save time, and improve customer satisfaction. And it's very similar to kind of the same thinking about PDCA cycles. It's a process of continuous improvement, but it's providing some more structure around it. We tend to see Six Sigma projects be a little bit longer than kind of rapid experiments in kind of a lean organization. So again, if we're thinking about the statistical definition of Six Sigma, you would essentially all of your opportunities, if you could think about them falling in the spectrum of, right, they're normally distributed, and only on the very tail end might you get something that either has specifications that are too low or too high for what you're trying to achieve with your product or your service. So again, that would equate to only 3.4 defects per million opportunities. Whereas the program, and it was originally developed by Motorola, but was adopted and enhanced by Honeywell and GE, is a very structured approach to process improvement, and we tend to refer to it as DMAIC. So DMAIC stands for defining, first and foremost, the project's purpose, its scope, outputs. So if you want to improve your quality by so much, again, we typically try to strive for 0 defects, but if you were thinking about it from a quality standpoint, you might have the project purpose explicit in terms of what operation or process are you looking at, and what sort of quality defects have you been experiencing, and what levels do you want to get to. Then the second step would be to actually measure the process, getting some of that baseline process data in terms of the step sequence, the timing, understanding where the quality issues are happening at each step in the process, collecting all of that data. The third step in the DMAIC process, A, is for analyze the data and to ensure repeatability and reproducibility of whatever sort of countermeasure you're trying to put into place. I is for improve, by modifying or redesigning existing processes and procedures. Again, that's kind of that experimentation phase where you assume or you have some sort of hypothesis where if you change the process in this way, then you would expect, again, your defects to decrease, for example. So you're making some sort of improvement to the system. And 5 is control. So assuming that experiment worked and you were able to reduce your quality levels, then how do you kind of maintain or sustain the gains of whatever that process change was that you made? All of these kind of total quality management concepts all fundamentally come back to employee empowerment, making sure that quality is not just something that is done by leadership. In fact, Deming often would describe that he believes that a lot of the quality defects actually stem from management, either not having clarity and objectives, or not getting processes set up right the first time, or not engaging their employees and training them appropriately. Really, all of the quality improvement efforts that are sustainable over time rely on the fact that the people, your frontline workers, again, irrespective of whatever industry you're in, they understand their job thoroughly, they feel vested, and they know what the goals of the organization are. If they're trying to improve a specific process, you know exactly what the goals are of that process and what the current issues are. And then as they see things when they're doing their job, every single day, they can either be a part of the data collection and understanding where some of the issues are occurring. At the same time, though, we're using all of their expertise in doing the jobs day in and day out to try to help us figure out how we can make it a little bit better. What type of experiment should we run? How could we redesign the process or use a different piece of equipment to prevent those errors from happening in the future? So inspection is a key term in quality. So inspection, there's a lot of different ways that we can think about inspection. Most people think about inspection at the very end of a product or the delivery of a service. So if you're working in fast food and you're thinking about delivering a meal to the customer at the window, or you could think about inspection as being at, inspecting that final bag of food, meal or drink before giving it to the customer. You could think about final inspection in any sort of manufacturing environment as to having a final inspection process at the very end of the production line to make sure that the product meets all specifications. But there's a lot of issues with this. So final inspection, it's really tiresome. It's difficult to make sure that somebody has kind of the mental capacity to be inspecting constantly and to be catching these things. Again, we're only human, so relying on inspection, from a human standpoint, it's certainly not, it's not the best way to go. And you can't inspect quality into a product. So what that means is essentially if you find a quality defect at the very end of the process, you can't go back and fix it in the very beginning. You're kind of left with a defect. You caught it, which is great that it didn't get out to the customer, but you still have a defect on your hands. Another approach is source inspection. So source inspection essentially means that the person who is doing each step is inspecting the product before they give it to the next person. If there is any sort of inspection being included into our quality improvement program, source inspection is typically the best way to go, making sure that the person who's doing the work is inspecting and making sure it's correct before passing it off. The benefit to that is that you're not having quality issues kind of permeate throughout the entire process. You're catching them at the root cause. That's going to help you be able to problem solve and figure out whatever the root cause of the error defect might be a lot easier than if you wait, a day or a number of process steps until it's all the way at the end of the line and then coming back and trying to figure out why it may have happened. So when we talk about inspection and quality, and we talk about source inspection in particular, Poka-yoke is a concept of basically foolproofing devices or techniques so that you're actually not physically capable of passing on a defect to another person. So this could be sometimes in manufacturing. We have something called a go-no-go gauge, where you would actually have something where you fit the part in, and if it fits, great, you can pass on. It means it meets all your tolerances and specifications. If not, obviously there's a quality issue with it. We see this when we go on our tour of Anheuser-Busch. So there's source inspection, and this is done, in a much more high-tech way. So looking at O2 levels in every single beer that passes through on the assembly line, looking at fill levels. If the fill level is not at exactly 12 ounces, it will be kicked off and it will be dumped out. So that also gives you quality information. And if you see a number of quality defects, then you can go back to exactly where those defects are happening and figuring out how to fix them. So last but not least, there are 7 quality tools, which I want you to know. I will link to another video that goes through these quality tools in more detail. But for people doing quality improvement work, the quality tools are kind of, it's the basis of what we do. They're tools for generating ideas, for gathering data and organizing the data in a very straightforward way to help us figure out what's going on with our process and where do we need to focus our attention. And then we also have tools for understanding, which we're going to talk about in the second section, more specifically statistical process control charts, and understanding, are the defects that we're seeing a part of kind of the normal variation in our production process, or is there some sort of assignable cause that we have to get to the root of to figure out how to fix so that we can improve our overall quality levels.